Alright, here we go. We're going to cover two basic concepts that hopefully you're already familiar with. Okay? And those two concepts are perimeter and area. Perimeter, of course, is the distance around something. So distance all the way around something. So as an example for you, let's say I have this crazy little polygon here, and it looks something like this. I told you that was 1, that was 2, that was 1, that was 2, that was 3, that was 1, that was 2, that was 1, that was 2, and that was 1. How would you find the perimeter of that crazy little polygon right there? We would just add up all the outsides, right? The perimeter, we're going to use a capital P for perimeter. It would just be, 1 plus the 2 plus the 1 plus the 2 plus the 3, all the way around, right? So the perimeter is all these sides, of course, added up together. Boom, just like that, all the sides. Okay. Then area, okay. Area is how much stuff would be on the inside of that polygon. So let's say I had this polygon that looks something like this. What do we call this polygon, ladies and gentlemen? What's that? How many sides? 1, 2, 3, 4, 5, 6 sided. What would that be? That'd be a hexagon. So if we're talking about area, ladies and gentlemen, then we're talking about either the shaded region on the inside or how much stuff is on the inside. So we're talking about all this stuff that fits on the inside here. Area is measured in units squared. So you've always got to put a unit squared. Sometimes the area could be feet, could be centimeters, could be inches, but whatever it is, it's units squared. We're talking about how much stuff is on the inside. So whenever you have your units, talk about units squared. Perimeter will always be a length, right? A length, because you can match each side to the number line, count all them up. So perimeter would be length, area would be how much stuff is on the inside. Okay, so check this out. We have a square here. We're going to talk about two things from the square. We're going to talk about the perimeter, and we're going to talk about the area. Okay, here is our square. We're going to talk about the two things, or we're talking about area and perimeter for a square. Pretty straightforward here. Since a square, what's so special about a square? What makes a square a square? Well, the sides are the same, right? So we're going to call a side just, how about an S? So if that's an S there, then what's this length over on the left-hand side? That would also be S. How about this one down here? S down here. What about this one over here? So then the perimeter, which we're going to use P, so the perimeter would just be this, all of the lengths added up together, right? So an S plus another S plus another S plus another S. Is there a better way we could write that? Yeah, 4S. There you go. So the perimeter of any square is 4S, where S is just a side from here to here. Okay? Now, if we go talk about area, which we'll do in purple, then we're talking about all of the area inside the stuff here. So the area for us is going to be this side, right, times this side. Yeah, S times an S. Well, there's a better way we could write that. What would it be? Yeah, it would just be a side squared, right? So, perimeter and area of a square. Okay, so we have a rectangle now then. So what makes a rectangle a rectangle? It's two pairs of congruent sides. What else do we know? Yep. Okay, so we're used to calling this a perimeter or a rectangle that has a length and a width. So if this distance down here, if this is an L, what's the one on the top have to be? Also another L, right? And if this distance over here is a W, what's the one on the left have to be? A W as well. And of course, all of these are right angles because it's a rectangle. So the perimeter, capital P, right, is going to be an L plus an L plus a W plus a W. Is there a better way we could write that? 2 L's plus 2 W's. So there is our perimeter formula for the rectangle. And we'll go purple for area. Area now, so is going to be the length times the width, right? Because we're talking about all the stuff that's in between. So we multiply our length and our width. The book has you graduating and calling this now a base and this now a height. Yep. So you might see it as base times height, and that's what we're going to use too. So area of a rectangle, base times height. Perimeter, just 2L plus 2W. Alright. This is called the area congruent postulate. It is so unbelievably basic, I'll bet you could figure it out. So I have two congruent figures on the right hand side. I have a blue figure and I have a green figure. How do you know they're congruent? Yeah, their sides are equal, and I did edit, copy, edit, paste, and I didn't change the sides of it, right? So I have the green and I have the blue. Okay, there's an if statement, and then there's a then statement. And when you think about it, it says if two figures are congruent, and think about it, the name of this postulate is called the area congruence postulate. Omid, what do you got, buddy? If two figures are congruent, then the areas, they have the same area. Good. They have the same area. They have the same area. Okay? Okay, I'm going to see if I could not write down in words what the area postulate says, and instead just give you a picture. Who thinks they see what I'm trying to say? Adrian, you're very excited. What do you see that I'm trying to say? Could you put this picture into words?
The top of it is like a rectangle, and the bottom of it is that little rectangle, and those two added together equal that shape.
Very, very good, man. Very good. So, if I call this figure A, and I call this figure B, then that's figure A and that's figure B, right there. So, you can break up the areas so long as what? You cannot have overlapping parts. Right? You cannot have that. Right? I couldn't say, for example, take this thing and move it like inside here and see where the green is. Oh, look how cool is that. Now, oh, look at that. See, it needs to stay out and needs to be out. Wow. That is actually pretty darn cool. See, that no longer has the same area, but that does. No. Yes. No. Yes. What about it big over here? Does that still have the same area?
Yes.
Sure does, because they're overlapping. What about that? No. How about this? No. Yes. No. Yes. No. Okay, it's kind of fun. All right. All right. Let's talk about units for a moment here. How many? If I was moving across the top here, how many units? How many boxes do I have across the top here? 1, 2, 3, 4, 5. Okay. So if I called this 5 inches, okay, what will this one be down here? This would be 3 inches, right? If I go, so that's 3 inches. This is 5 inches. Okay. Okay, so if I talk about area, okay, the area of this would have to be the base times the height. So that would have to be 5 times the 3, right? So that would be what? 15 inches squared, okay? So why does it become inches squared? Because units are in squared, because what this means is I actually have, if I broke this up, right? If I broke this up into individual little boxes, right? This, like this and this and this and this, and this one over here, and this one over here. How many boxes do I have total? Yeah, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 little squares, right? Little square. That's why we have a squared unit in here. So anytime you're dealing with an area, you have to have a unit squared. So sometimes you'll see this picture. All right? You'll see the exact same picture, except the book will just give you a 5 and a 3. And ask you for the area. So you would say then area is equal to 3 times 5. So that must be 15. But what do you do for units squared? If they don't give you a unit, then you actually have to put a U square for units squared. So if they give you inches, then you're going to do inches squared. If they give you nothing, you're going to do units squared. Okay, so we're going to do 4 examples together. Here's the setup. We have A, B, C, and D. These are the 4 examples that we're going to do, A, B, C, and D. A and C are squares. B and D are rectangles. So, if I tell you that this side is 15 units, I want the area and I want the perimeter. This one together. So for part A, if you know that this is a square and one side is 15 units, then the area is going to be what? The area is going to be 15 times 15, which is what? 225 units squared. Very good. That, and then the perimeter would be what? 60 units. Very good. Okay. So here's part B. if I give you that this is 12 inches and this is 3 inches. For area, our area is always squared, our perimeter is not, because perimeter is the length. Okay, for part B, I want the area and I want the perimeter. So area is going to be 3 times 12, so 36 inches squared. The perimeter is going to be 2 times 12 plus 2 times 3. So that's going to give us how much? 30 units. Because I need to add up all the way around, right? Each one of these. There's 2 12s and there's 2 3s. Oh, what, I give you inches here? Oh, thanks. Inches, thanks. 24 and 6, right? Is that 30? Yeah, we're good. Yeah, we're good. Okay, part C. I'm going to give you, this is a square. I'm going to tell you the area is 49 units squared. Give me the perimeter and give me a side. Okay, so if the area is 49 units squared, what does that mean? How do you know each side is 7? 49 divided by 4? Don't you just take the square root? Isn't that right? Because if it's something squared, right? If it's a square, so that means that the side has to be 7 units, right? And the perimeter has to be what? Yeah, 4 times 7, right? It'd be 28 units. 28 units. Very good. Okay, for part D here, I'm going to tell you this. This is a rectangle, and I'm going to tell you the area is equal to k squared minus 4k. Okay, part D, probably a more challenging question. So let's zoom in and move it over here. Okay, here's D. The area of the rectangle is k squared minus 4k. How do you find the perimeter? And how do you find the side? Okay, yeah, what do you think? What do you think, Issa? Do I do what?
Hermine.
Yeah, what is that called?
Foil.
Okay.
Yeah, foil it.
Yeah.
Like you do, sorry, that's what we called it last time.
Actually, I forgot to tell you that this side was K. There we go. That might help you. Sorry.
That should help.
That should help. So that side's K. Then what's the other side? Okay, so then this side has to be K minus 4. Why is that true?
Because k times k minus 4 equals
Yeah, okay. So this, we can break this down into, since the area is the base times the height, and we know, so this is going to be K times what would have to give us K squared minus 4K. So that would be a K minus a 4, right? So the base and the height are K and K minus 4. So then I don't really need S in this case. So what would the perimeter be? The perimeter would be 2K minus 4 plus 2Ks, right? Because I have a top and a bottom and a left and a right. Does that make sense? So when we deal with algebra, it takes a little bit more thinking. So then the perimeter would have to be 2K minus 8 plus a 2K. What's 2K minus 8 plus 2K? 4K minus 8. So the perimeter is 4K minus 8. And the side lengths, or the base, is K minus 4, and the height is a K.